Hi there, I'm Daniele Reda from Padova.
And I'm Francesco Pieri from Salerno.
We're attending the first year of Computer Engineering Master Degree here in Politecnico di Torino, and we had the opportunity to develop a research project during the Computer Architecture course held by Prof.Montuschi and prof.Sanchez.
In particular, we were requested to explore the field of machine learning in the context of simple computer graphics applications, headed by prof.Lamberti and researcher Paravati. Our task was to create a predictive model to correlate mouse and gaze movements using an existing framework which exploits an eye tracker like this one.
So, what does this mean? First, we had to record both mouse and gaze traces on the screen, and this was done using a Java application and the i5 recorder.
Afterwards, we used Microsoft Azure Machine Learning Studio, which is a web-based application that allowed us to work with our data and start developing our model.
The Java application allows you to replay, record, and convert gaze and mouse data. Replay allows you to replay existing data, both with predicted quadrant and graph with only mouse and gaze. To show also the predicted quadrant, it is asked to specify the amount of quadrants of the prediction and the name of the column in the CSV file of the predicted quadrant. Calculate error allows you to evaluate the error of an already predicted recording. Obviously, it is requested to specify the amount of quadrants. And convert into quadrants allows you to change the amount of quadrants in a previously recorded test. Record allows to record a new test. It is asked to insert the record name, and you can decide to convert directly the data in quadrants or to convert it afterwards with the Convert into Quadrants menu. It allows you to decide if you want to record only the mouse movements, only the gaze ones, or both. Once decided, pressing the record button will open the live trace of the recording. To actually start writing gaze and mouse data on a file, there is a button to press. We decided that the button to start the recording was M and to stop it was N. For our tests, we simulated basic actions on Blender: grab, scale, and rotate. And when recording is finished, the CSV file is ready to be imported in Azure to work on the prediction part.
Okay, this is the Azure environment. You can see several blocks. In this one you should enter the input data, so both the training and test sets, in the following format. You just copy them from the CSV files as they are produced by our Java application. And for the test set, in our case, there is a single experiment, so you can see fewer lines. Then you modify input data and you select certain attributes that will be used by our predictor. So of course you select mouse gaze and timestamp, which is a normalized timestamp. Then you tune the algorithm. So you choose number of decision trees, the maximum depth, the number of random splits. You can see here our configuration, which runs in about 2 minutes. And finally you select the desired attribute that you want to predict. In our case it's the gaze, of course. Eventually you modify data, so you add again the columns that you eliminated at the beginning. This is done to let our Java application be able to reproduce the experiment. Here you can see a sample of the output of the score model box. There are different probabilities, and we based our probability error on these probabilities. Of course, the highest probability corresponds to the scored label. and eventually you just press run and run the experiment.
After predicting the gaze quadrant with Azure, we can replay the full test with the Java application. When selecting to replay the experiment with a prediction, it is asked to input the predicted gaze column name and the number of quadrants of the prediction. The replay screen will show three traces: the gaze trace in purple, the mouse trace in blue, and the predicted quadrant in green. As you can see, for the full time of the experiment, the predicted quadrant is constantly close to the real gaze. For further information on this study, please check the links on the description of this video. Thanks for watching.